Let's talk about right triangle trigonometry. In this section, we're going to be working with right triangles, so let's talk about how to label our sides of our triangles. Since we're going to be working with right triangles, obviously we have an angle measure that's going to be 90 degrees. You're going to see that denoted by a little tiny square in the corner, and the side directly across from that is going to be known as our hypotenuse. And then we're going to need to place our angle measure in one of the remaining two angle spots. So I'm going to go ahead and use theta as my angle measure, and I'm going to label it down here in this corner. Once I've placed my angle measure into my triangle, now I can go ahead and label my opposite side. The side straight across from theta is my opposite side, and that means that my last side here is my adjacent side. Now, I went ahead and gave them some labels here. I'm going to call my adjacent side, side A, my opposite side, side B, and my hypotenuse is going to be C. Because we're working with right triangles, obviously you can use Pythagorean Theorem, so you have the formula a squared plus b squared equals c squared. Now, let's go ahead and talk about the 6 trig functions that we're going to be using. Each of these functions is going to be relating an angle measure to a ratio of side lengths. My first trig function is sine of theta, and this is going to be equal to my opposite side over my hypotenuse. Cosine of theta is going to be equal to my adjacent side over my hypotenuse. Tangent of theta is going to be equal to my opposite side over my adjacent side. If you've taken trig before, you've probably heard the phrase Sohcahtoa. This is a little mnemonic to help you remember those 3 trig functions. Sine is equal to my opposite over my hypotenuse. Cosine is my adjacent over hypotenuse. And tangent is my opposite over adjacent. Let's go ahead and take a look at the other 3 trig functions. Cosecant, abbreviated CSC, cosecant of theta, is equal to my hypotenuse over my opposite side. Secant of theta, abbreviated SEC, is equal to my hypotenuse over my adjacent side. And cotangent of theta is equal to my adjacent side over my opposite side. So let's go ahead and take a look at an example where we're finding each of the 6 trig functions. So I've got a right triangle, and 2 of my sides are labeled here, and I have theta down here in this corner. That means this side is going to be my opposite side. Once that side is labeled, I can go ahead and label my hypotenuse. That's the one across from my 90-degree angle, and that means my last side here is my adjacent side. So let's go ahead and use Pythagorean Theorem to find our last side length. So I've got the formula a squared plus b squared equals c squared. I'm going to use an a value of 3. My hypotenuse is 5, and I have each of my pieces plugged in here, and let's go ahead and solve this for b. So we're going to get a side length of 4, and that's going to be my opposite side. Now let's go ahead and find our 6 trig functions. Sine of theta is equal to our opposite side over our hypotenuse. Our opposite side is 4, and our hypotenuse is 5. So sine of theta is going to be equal to 4/5. Cosine of theta is equal to our adjacent side over the hypotenuse. Our adjacent side is 3, and our hypotenuse is 5. Tangent of theta is equal to our opposite side over the adjacent side. Our opposite side is 4, and the adjacent side is 3. Cosecant of theta is equal to our hypotenuse on top and the opposite side on the bottom. It's really just the reciprocal of our sine function, so we're going to get 5/4. Secant of theta is equal to the hypotenuse over the adjacent side, which in this case is 5/3. And our last trig function is cotangent of theta. That would be the adjacent side over the opposite side, which would give us 3/4.